talking about, the topic I will be talking about today is, can an old brain learn a new language? And I'm not an expert in this area, but it's an area that I find to be very fascinating, and I'm really interested in it. I'm just beginning to learn about it. So tonight I would like to share with you what I have learned so far. And if you're also interested in this area, I'm also, I hope to learn from you as well. So please share this. Okay, sorry. Getting messages on my screen. Okay, if you have any questions, please ask me at the end of the presentation. The reason is that if you can't tell, I'm really, really nervous, and I don't think I can take questioning while I talk. So please bear with me, hold the question until the end. Okay, so now I'm going to share my screen with you. Okay, can we see this? If you can see it, give us a thumbs up, please.
Looks good.
Thank you, McGill. Thank you. Okay. Oh, wait a minute. Okay. Now I would like to begin my presentation. The title is, Can an Old Brain Learn a New Language? Neuroplasticity and the Critical Period Hypothesis of Foreign Language Learning. I will be talking about the following 4 topics. First, a brief introduction about neural development, and then the critical period hypothesis. The third topic will be neuroplasticity and language acquisition. And then finally, sort of a sum up last statement about the application to learning. And in this presentation, the terms foreign language and second language will be used to mean the learning of a new language. So I will use them somewhat interchangeably. Okay, so the first topic, neural development. Here we see a picture of 2 neurons. A neuron is a specialized cell transmitting nerve impulses to and from the brain. And a very important area that I would like to draw your attention to is this encircled area. This area is called a synapse. It's the end point of a neuron, and it's also the place where neural impulses are passed from the neuron to the next neuron. As we people, as well as babies, experience new things and learn new things, the synaptic connectivity, or what we call neural network, increases. And this is a dynamic process. So the synapses will get connected, and it may get disconnected, and then it may get connected again. So the overall neural network can increase in volume, and they can decrease and increase again. And I'm going to explain a little more. This is a graph showing the general development of our neural networks. At the very beginning, at the left side of the graph, is when we grow as babies, that when babies are born, they start receiving a lot of stimulations from the environment. So the nerve connections or the synapses begin to grow very rapidly. And it continues to grow and reaches the peak at about the age of 2 to 4 years old. So the number of synapses is the most at about 2, 3, 4 years of age. And after that point, the number of synapses actually begin to decline. And when it gets to about the age of 16, the decline will sort of level off, and we see sort of a flat, about maintaining about the same number, overall number of synapses in all throughout our adulthood. And this pattern, this change in this trend in development is also known as synaptic pruning. I would like to point out to your attention is that the neural networks still continue to have this increase, decrease kind of dynamic processing even after the age of 16. So it's not like we have growth in the number of synapses and then drops and then flatten out and stay there. But every day our synapses grows, increases, and decrease. The points about the synaptic pruning is that it is a natural development process. This is part of maturation. But why would our body, why would our brain do this? Wouldn't more be better? Just having a lot of synapses, a lot of pathways, a lot of connections, wouldn't that be the best for human as a species? So what is the purpose of synaptic pruning? Synaptic pruning appears to have the function of refining neural circuits and increasing network efficiency. It's like there may be many, many different streets, different routes that we can take to go from our home to our workplace. But eventually we will settle down to maybe the fastest way or the widest, the safest way to go to work. So the pruning part is really like just limiting and narrowing down to the best way to take us to where we want to go. Are there any rules that our brain follows when they do the synaptic pruning? And it seems like there's the rule of use it or lose it. Use it or lose it. Okay. Leave that sort of in the back of our head, and let me move on to the next topic. And the next topic is the critical period hypothesis. Critical period is defined as certain environmental events must happen at certain times in the development of an organism in order for normal development to occur. And critical period hypothesis is a hypothesis related with L2 attainment. This is defined as age-related effects in L2 ultimate attainment due to the existence of a critical period for language acquisition. And people who support the idea of critical period hypothesis said that there are two main points. The first one is during the critical period, the learning is assured and learning is similar across all individuals. And this learning is governed primarily by endogenous factors. So it's a natural inborn, it's in our DNA that during a certain period that we can maximize, or we are very sensitive, we are very, very sensitive to any environmental stimulus, and we learn the best in this period. And they also said that outside of this critical period, the learning is less certain and more erratic in its outcome. And so the key point here is that there is a clear discontinuity, and the time of that discontinuity should reflect the close of or the ending of the critical period. So there's a distinct time point where the learning ability to learn or the efficiency will drop dramatically. So for people who try to test the critical period hypothesis, they concentrate on usually the two main questions. One is that, is there really a critical period for L2 acquisition? And if yes, when, at what age is this critical period? And to tell the end of this story is that they actually have very conflicting results from their studies, and there's still no consensus from their research studies, from their research results. I will tell you two examples, give you two examples of research. One is by Johnson and Newport in 1989. They hypothesized that young children can reach higher levels of final proficiency in L2 than adults. And they asked 46 native Korean or Chinese speakers who arrived in the US between the age of 3 to 39, and they have lived, there is a chat, sorry. Oh. Sorry. And they have lived in the US for about 3 to 26 years. And Johnson and Newport gave the participants a set of grammar tests and asked them to judge, for example, read this sentence, is there any grammatical error in this sentence? Tests like that. And what they found was, in their research, they found a clear and strong advantage for people who arrive in America early, which means at a young age. And the test performance was linearly related to age of arrival up to puberty. And after puberty, the performance was low, and the performance was also highly variable and unrelated to the age of arrival. So they concluded that their research findings supported that there is a critical period for language acquisition, and it's the same effect. The critical period applies to second language acquisition because there is a clear-cut point at which the level of performance dropped and the age effect disappeared. However, in 2001, Birdsong and Molis, they actually replicated the study by Johnson and Newport, and they recruited 61 native Spanish speakers who arrived in the US between the age of 3 to 44, and they have lived on an average of 10 to 12 years in the US. And they gave them the same tasks that Johnson and Newport used in their study. And they have found that their participants performed much better than those in the Johnson and Newport study, and the L2 attainment was negatively correlated with age of learning, even when the learning started after the presumed end of the critical period. So, which means that the age effect continue even after, say, after puberty. So they just keep continuing. There's no clear end point for the critical period. And also, they found some evidence of native-like attainment among even the late learners. So they concluded that their research finding did not support that there is a critical period for L2 acquisition. And they argue against the critical period hypothesis on the 3 points. First, the most supporters of critical period hypothesis argue that there's the age effect prior to, but not after the end of maturation. So there's that end cut. But in Birdsong and Molis, they actually found a continuous age effect even after the expected critical period. Also, the second point often argued by the people supporting critical period hypothesis said that there is almost zero, it's impossible of L2 learners, late learners to achieve native-like level of attainment. But in their study, they actually found few cases, but there's few, but there's still evidence of native-like performance. And the third point often argued by the critical period supporters is that because this is a natural occurrence, the critical period is, so it doesn't matter how similar or how different between L1 and L2, the results should be generalizable. However, in Birdsong and Molis, they actually found that their Spanish native speakers perform much, much better than the Korean and Chinese native speakers in the Johnson and Newport. So they suspect that maybe the similarity between L1, which is Spanish, and the target language L2, which will be English in this case, maybe the similarity between L1 and L2 makes a difference. So it's not like universal, as Johnson and Newport would argue. So the two main questions: is there a critical period for L2 acquisition? Among all the different research, the conclusion is, well, some people say, yes, there is a critical period. Some people said, no, there is no such thing as critical period, even though there is the age effect, but there's no clear cut. And then there's a group of people taking the middle road and say, maybe there is something called a sensitive period. What is sensitive period? A sensitive period is defined as a stage in development when an organism can most rapidly acquire a particular skill or characteristics. And the lack of appropriate growth-dependent experiences during that sensitive period does not permanently and irreversibly affect development, as it would for the critical period, but rather make the acquisition process outside the period just more difficult. So here, for the supporters of sensitive period said that if we learn during that period, we can learn faster. But if we didn't learn second language during that sensitive period. It doesn't mean that we can never learn it. It just makes it more difficult to obtain the skill. Okay. So the second question, if there is a critical period, at what age is that end point? And here, even for the supporters of critical period hypothesis, some says it's at age 1, and some says no, it's at age maybe 6 or 8, early elementary school, and some people say, well, at puberty. For people supporters of sensitive period, they tend to have a longer period. The endpoint is more extended, and they said they have proposed that maybe the sensitive period ends around late teens or early 20s. So we see a variety of age that people are proposing as to at which point or at what age that this very important window of opportunity ends. So as I have said earlier, that the results have been very inconsistent, and there's no consensus in terms of the research results. And there seems to be more people now moving from proposing or supporting critical period to sensitive period. But for all people doing research in this area, they all seem to have found age effects for language learning. And then some people, especially more recent research, they found the mastery of learning new language is possible even for late language learners. Okay. This is just my thoughts. Thinking back to the graph of the development of synaptic network, the networking, we saw this graph of increasing and then decreasing. And I just wonder about this debate between critical versus or sensitive period, if they can be looked at from this perspective. And I wonder if this, before 4 years old, this rapid increase in our neural network, does that mean that because we have a large number of synapses, we have a lot of room to maneuver, this will be a time, like ideal time for growth to accept, to learn new information, to accept new stimuli? So would that be sort of what they mean by critical period? And then this area after the age of 16, this more efficiently connected neural network, but having fewer number of synapses, would that be the reason underlying that we can still change because of that increase, decrease dynamic process, but still we may feel a little more difficult just because the number of synapses is fewer, even though it's more efficiently connected? And I wonder if that sort of coincide with what some people are saying, the sensitive period. And this is just my thought, and I just wonder if I can sort of look at their research find this inconclusive research finding by using the idea of synaptic pruning. So if you have any thoughts, feel free to share at the end of my presentation. Okay, let me proceed. Okay. The next topic that I would like to talk about is neuroplasticity and language acquisition. What is neuroplasticity? Neuroplasticity is a coined word including the neuro and plastic. And neuro here is, of course, is relating to nerves or the nervous system. And plastic means to mold or exhibiting adaptability to change or variety in the environment. And often when we talk about neuroplasticity, the research really started with sort of brain damage, that when our brains are injured, we suffer from damages and losing functions. And then somehow we find that our brain can somewhat readjust and still like shift the functions. Generally, there are two ways for our neurons to adjust itself. One is by synaptic connection. So there could be added connection, and sometimes the connections can disappear. And the second one is that when a part of the brain is damaged, the functions controlled by that location in the brain can actually be moved. So the entire location now damaged, the functions will be transferred to a different location in the brain, and that new location would now be regulating or managing the functions. And how people started looking at neuroplasticity and language acquisition actually probably started from observing people who regained their language abilities after suffering from brain damages caused by stroke or other injuries. And eventually that led to the question that this language learning and training can help or lead to structural changes in the brain, hence neuroplasticity. And then, of course, there are many research in that field, and some of them related to second language acquisition are generally conducted in the following two approaches. The first one is they compare differences in brain structures between the monolingual and the bilingual or multilingual people. And the second approach to examine is they try to see if there are changes in the brain structures after the language learning or training sessions. And I will give some examples from each approach. The research dealing with comparing the brain structure between monolinguals and bilingual or multilingual linguals, they tend to have this research design. They will recruit a group of monolinguals and a group of bilinguals or multilinguals, and they will take MRI or a functional MRI to obtain brain imaging data. And then they will compare to check for any structural differences between the two groups of people. Research conducted in this approach has used a different group of people. For example, in one research, they used in 2019, they used university students. The L1 is English and L2 is L1 is Chinese and L2 is English. And in a different study, there's in 2014, they used young adults, age between 20 to 40, and their L1 is Spanish, or monolingual is Spanish, and the bilingual speaks Spanish and Basque. And then there, of course, there are many different research, but similar research design. And the research finding has been pretty consistent. The bilingual people, they show greater gray matter density, and they had higher white matter integrity in several areas of the brain, especially area related to vocabulary knowledge, related to phonemic fluency, and so on. And also very interestingly is that they found also the greater volume amount of the gray matter and white matter also found in areas related to executive functioning, such as code switching and control. Code switching is like they see who they are talking with. If the other person speaks language A, and they will use language A with the person. If they see another person speaking language B, they will use language B to communicate with this other person. So there's they can switch between the two languages, 2 or 3 languages. So that's a general finding from this approach of research. And the second approach, comparing the brain structure change before and after language learning, they also follow this same, this general research design is that they will recruit students and they give them language training, and then they will measure the students' brains before, some during, and after the training, the language training. And then different research created different training conditions, and I'll just give some examples. For example, this research published in 2012, they recruited exchange university students from America who are studying German in Switzerland, and they gave them 5 months of German training and compare the brain structure before and after. And this other research also published in 2012, they recruited a group of students at a military academy, and these students are studying to become interpreters so that they will be dispatched to different countries. And they received 10 months of very intensive language training program. So again, here we have different types of people, different ages, learning different languages, different time period of the training. But overall, what they found was that the trainees, they show an increase in gray matter density and in white matter tract connectivity. And also they found the trainees show increase in the areas related to phonological processing when the second language, when the language that they are learning is a tonal language like Chinese, Thai, Vietnamese. So the area for the sound phonological processing is also getting bigger, or more connectivity, more development in specific area of the brain. And there's one very interesting study that I came across and I thought it deserves special mention, is a group of researchers, the Hosoda and his colleague published in 2013, is that they had a group of native Japanese speaking university students in Tokyo area. And they had a training group, and they also had a control group where they didn't receive any training. And they gave 16 weeks of studying vocabulary for TOEIC tests, and they measured their MRI of the brain before the training, at the end of the training. And they also gave the MRI scanning 1 year after the training course, where students, they didn't continue the training, but just let students do whatever. And the results showed that students receiving training, they showed an increase in gray matter and white matter density in the right hemisphere, the area controlling language perception, and as compared to the controls, people who did not receive any training. And in their 1 year follow-up MRI scan, they found the gray matter density actually returned to the pre-training levels for those who didn't maintain or who didn't continue to practice the vocabulary. But the growth continued to increase. The growth continued for those participants who practiced on their own for 1 year after the training had ended. So what we can say from the research results conducted by this approach is that language stimulation do lead to structural changes in the brain, and the use it or lose it rule of pruning applies. So I thought that was pretty amazing. Okay, so what does that mean for us, the old brain learning a new language? I'm going to answer this question. I don't know if this is a correct answer or not, but can an old brain learn a new language? I think from what I read so far, it may take more time and effort, but I would like to say yes. People like me, like us, can obtain certain levels of proficiency even when we start learning after puberty. There's no data showing at what age, but for sure after puberty, that in their 20s, in college age, that we do see the increase, the change in the brain. And there's effect. We are actually stimulated by the language, and we can learn. Yeah. Thank you very much for listening. Okay.
Okay, a big round of applause for you, Yuwen. That was fantastic. Thank you very much. Excellent, excellent.
Yeah.
Okay, so we have time for questions. But before we begin, just a very quick announcement for you. If you did enjoy tonight's presentation, please remember you can find more presentations just like tonight on the JALT calendar. I'll put a link in the chat. And our next presentation from Nagano JALT will be on November the 25th by Colleen, who is here tonight. If Colleen, you'd like to say a quick words about your presentation?
Oh, thank you, Yuwen. Yeah, just next month I'll do a short presentation on multiliteracies, which is not a new word. It's a word from the 1990s, but it seems this is the moment to talk about it again, because what's happening inside the classroom is a real opportunity to